Let's continue our lecture video on derivatives of trigonometric functions. Now here for sample number 6, find the derivative of tangent x sine x. So if you notice, this is the angle of tangent here. So therefore, x sine x is the u. Okay, so u is x sine x. Now, for the pattern, for the derivative of tangent, we have there tangent u is equal to secant squared u, and then the derivative of u. But first, let's derive the u here. So, to derive u, if you observe, we are using the pattern derivative of sine u, which is cosine u and then derivative of u. Also, we can observe that here we have x and sine x. Therefore, we are using derivative of a product. So, derivative of d dx of ub is equal to u derivative of v over dx plus v derivative of u over dx. So here, that means this is the u and then this is the v for the derivative of the product. So we're going to use these three patterns here in solving problem number 6 or example number 6. Okay, now let's derive u. Derivative of u is equal to derivative of the product, so x, and then derive sine x. Derivative of sine x is cosine x. Then plus, this is the v. So sine x, then the derivative of x is 1. Okay, so we're using this pattern, right? And that is equal to x cosine x plus sine of x. Then, going back to the original equation here, the top, we now derive tangent x sine x. So, using this pattern, derivative of tangent u is equal to secant squared u. So, let's write here. Secant squared u here is x sine x. And then, the derivative of u. So, the derivative of u, which we have solved a while ago, which is x cosine x plus sine of x. Okay? So, what will happen here? We cannot multiply this angle only and distribute it here. No. We are to distribute, or if we prefer to distribute it, then it should be the whole secant squared x sine x to be distributed here. Always remember that this is the angle of secant squared. Okay? So the final answer now here is, this is actually secant squared x sine x, x cosine x plus sine x. So that is the final answer. Okay? So that's for sample number 6. Let's go for example number 7. For example number 7, we need to find the derivative of 1 plus sine sine y to the 4th power, and this is to the 3/2. So here we can see the pattern as the derivative of sine, which is cosine u, derivative of u, and we're going to use the power formula. since you're seeing here a power. So if we're using the power formula, so the power formula here, this becomes the u for the power formula, this one here, and then this becomes the n. Then if we follow the pattern for the power formula, bringing down n, copy u, n minus 1, obviously this becomes 3/2 minus 1, and then we will derive u. So the u here is 1 plus sine to the 4th power, or sine y to the 4th power. Okay, so let's start. So using the pattern for the power formula there, or let's arrange it first. This is still equal to, this is still similar to this one. This is sine y to the 4th power 3/2. So this is still similar to that. Okay, now let's execute the patterns. dy. So power formula, bring down 3/2, copy u, which is 1 plus sine y to the 4th, then power minus 1, then the derivative of the u, the derivative inside. So let's derive what is inside here. So derivative of 1 is 0, plus the derivative of sine y to the 4th, another power formula. So again, bring down 4, copy u, sine y, 4 minus 1, then the derivative inside. So what's the derivative inside? The derivative of sine y. So what is the derivative of sine y? That is cosine y. And that's it. And let's simplify. This becomes 3/2. Then 3/2, this is 1 plus sine to the 4th raised to 3/2 minus 1 is 1/2. Then we have here 4, then sine raised to 3 y, because that is 4 minus 1, then cosine y. Then we can simplify this further. We have there 4 divided by 2, that is 2 of course, and then multiplied to 3, that becomes 6. So that is 6, 1, so 6, 1 plus sine y to the 4th raised to 1/2 sine y to the 3rd cosine y. So that is the final answer. Okay, so that is for example number 7. Right, next, for example number 8, we have there y is equal to cosine of square root of 2x plus 1. Now for our pattern, we have there the derivative of cosine u is equal to negative sine u derivative of u. Now since we are looking at the u for the cosine here, so this is our cosine u. Since the u here has a square root, meaning if we get the derivative of u later on, we will be using this pattern. Okay, so for the derivative of square root of u, that is equal to derivative of u over 2 square root of u. Okay, so let's execute the pattern. So again, for the cosine, so derivative of cosine is negative sine. So negative sine, then copy the u. U here is 2x plus 1. Then, after u here, we now derive the u. So what is the derivative of 2x plus 1? So that is du, which is inside of the square root. So 2 plus 0 over 2 square root of 2x plus 1. So you have noticed there's a lot of u here. So I'm doing it directly. So we can now cancel here 2. Since it's 0 here, so we can now cancel 2. So the final answer here is negative sine square root of 2x plus 1 all over square root of 2x plus 1. Now remember, you cannot cancel this one out. If you cancel this one out, then the answer will be negative sine of what? Negative sine of 1? No. You cannot cancel the denominator with the angle of sine. So this is the answer of number 8. Actually, there's another solution here. Or if you're not into the radical sign, but you're a fan of the power formula, you can use power formula here. So we can convert here cosine of 2x plus 1 raised to 1/2. So we can do that also. Then we can use the okay, so we can use a pattern of the power formula a while ago. So this becomes dy equals, for the derivative of cosine, we have negative sine of 2x plus 1 is to 1/2. So we are copying it. So we are at this point here. And then the next point is the derivative of u. Derivative of u, which is 2x plus 1 raised to 1/2. Yes. Do not leave this portion here because this is included as the u. This is not similar with negative sine 1/2 2x plus 1. No, this is not the same. Okay, so the 1/2 here belongs only, so the 1/2 here belongs only to the angle. So we are deriving here the whole angle here. So this is now 1/2 u of 2x plus 1, 1/2 minus 1, then the derivative of the u, which is 2 plus 0. Then that is negative sine 2x plus 1 raised to 1/2. Then we have there, we can cancel out now 2 here. So what's left is 2x plus 1 raised to negative 1/2. Again, you cannot multiply this with this portion here because that is the angle. Therefore, the final answer is negative sine 2x plus 1 raised to 1/2 all over 2x plus 1 positive 1/2. Okay. So these two are the same. So that's for example number 8. Next, number 9. For example number 9, we have there, find the derivative of x squared over square root of 1 minus sine 2x. Now, it's becoming more complicated, so we will need to simplify this further. Now, if you find the power formula more convenient, then this becomes 1 minus sine 2x raised to negative 1/2. Okay, so there you have it. Now our pattern for this, we will be using these 3 patterns. First one here is the derivative of sine u is equal to cosine u du dx, or derivative of u. Next, derivative of the product. So we are seeing here derivative of product because of the presence of u here and v. So this is the u and this is the v for the derivative of a product. Then we will be using the power formula because of the presence of the powers here. Right? So let's begin applying all those patterns. The derivative of y is now equal to x squared, and then derivative of the right portion, bring down negative 1/2, copy u, minus 1 the power, and then derive the what's inside. So that is derivative of 1 is 0 minus derivative of sine 2x. So what is the derivative of sine 2x? That is cosine u, cosine of 2x, and then the derivative of u, that is 2. Okay, that is for the first term only. Remember, we are doing a product, derivative of a product, so we still have the second term. The second term here is the v, 1 minus sine 2x raised to negative 1/2, then the derivative of x squared, that is 2x. Now, if you forgot this portion here, then most probably your answer, although this one is correct here, the answer for this example will be wrong. So always remember the pattern. Okay, that is equal to, let's simplify this further. That is x raised to 2, and then this is negative 1/2, 1 minus sine 2x raised to negative 3/2, and then we have there negative 2 cosine 2x. Again, we will not multiply this with the angle. Okay, so I think we haven't forgotten anything here. Then plus 2x 1 minus sine 2x raised to negative 1/2. And then we can now cancel out this 2 here, negative 2, so it will become positive, So, okay, so that becomes x squared 1 minus sine 2x raised to negative 3 halves times cosine 2x plus 2x 1 minus sine 2x raised to negative 1 half. Okay, and then let's put it in the denominator, the negative 1. So that is 1 minus sine 2x raised to 3 halves. Then what's left here is x squared cosine 2x plus 2x all over 1 minus sine 2x raised to 1 half. Okay, so the common denominator will be 1 minus sine 2x raised to 3 halves. So let's multiply this with 1 minus sine 2x 1 minus sine 2x. So that this becomes 3 halves. So this is x squared cosine 2x plus 2x times 1 minus sine 2x. Therefore, this is now x squared cosine 2x plus 2x minus 2x sine 2x all over 1 minus sine 2x raised to 3 halves. Okay, so we can have this as answer, or we can have this as answer. So x squared cosine 2x plus 2x minus 2x sine 2x all over 1 minus sine 2x raised to the power of 3 halves. Okay, or it's another answer here. So x cosine 2x plus 2 minus 2 sine 2x, still you can still use this as an answer. Okay, so this is the example number 9. Okay, last is example number 10. For example number 10, we need to find the derivative of secant 2 minus 3x cubed. Okay, so that is this is also y is equal to secant of 2 minus 3x raised to 3. Okay, then let's use this pattern. For the derivative of secant u, we have the answer secant u tangent u, then derive what is the u. In this case, our u here is the angle of secant 2 minus 3x and not included the 3. No. Then power formula because of the presence of exponent. Okay, so this is now dy equals, bring down 3, copy u, secant 2 minus 3x, then minus 1 the exponent, derive the inside. So that is secant u tangent u, then the derivative of the u. Derivative of 2 is 0 minus derivative of 3x is 3. and then let's simplify. This is now 3, then another 3 there, so we have there negative 9. Second is to 3, 2 minus 3x. No. Okay, so the reason why is a 2 minus 3x, then another second 2 minus 3x here, tangent 2 minus 3x. Therefore, the final answer is negative 9. Second, 2 minus 3x, tangent 2 minus 3x. So this is for example number 10. Okay, so that's all for the topic trigonometric functions.